First thing we have to do is you have to locate the center of the circle. And the center of my circle in this case is right here at the point 2, 3. Those are the coordinates of that point. So that's the center of the circle. So my equation is always x minus h squared plus y minus k squared equals r squared. hk are the coordinates of the center. Now, a lot of you aren't taking any notes, which is why you didn't know that formula at all or how to use it. But we did this exactly yesterday. This is what the whole day yesterday was about. So here the center is hk is 2, 3. So it's just x minus 2 squared plus y minus 3 squared equals r squared. The radius of this circle is very clearly 2. So 2 squared is 4. Well, all they did is change the scale of the thing. So if we scaled it, if they put a 10, 20 here and a 10 here, all it means to this is now 20, 30, and the radius is 20. Okay? So they're counting by 10s instead of by 1s, or 5s, or 3s, or whatever scale they happen to put on the graph. But that was what was going on with those. Whoops. Double clicked it. That doesn't give me a problem. There we go. Better? That's better. Okay. All right. But that's how we do it. We got to find the center and the radius and just use the form of the equation. But again, you're going to have to memorize that form of the equation. You have to know that and what h and k and r represent. That's what we spent the entire day yesterday working on. Same with one of the graphing ones, and say 22 is x squared plus y plus 2 squared equals 36. Well, x squared is the same as x minus 0 squared. So from this, I can get the center is at 0, opposite of this. So 0, negative 2 is my center. So 0, negative 2 is my center, right there. The radius is the square root of 36, which is 6. So the graph, I'm going to go 6 to the right. Okay, so that's 0, negative 2, that's 4, 0. 6 to the left would be negative 8, 0. 6 up would be negative 2, 6. 6 down would be negative 2, negative 6. And we just do our best to try to draw a circle that... We do our best. Or if we have a smart board, we can do that.
You were messing that up.
I'm off just a hair, but you get the idea. No, we can drag it down. Oh. There we go. That's pretty good. Okay? But that's the idea. But again, it has to do with center and radius of the circle, and you really do need to understand that formula and how it works. Yeah. No. Yeah, if you want to use a compass, you can use a compass to draw the circle. Yeah, the circle drawing thing tool. Yeah, it's a compass. You can do that. All right. So anyway, but yeah, you do need to know that formula. And believe me, that's just the first of dozens of formulas we're going to need to know this semester or this quarter. It's going to be a lot of formula memorization. That's the biggest problem for fourth quarter, which is why you want to be making your flashcards. I mean, seriously, equation of a circle, write the equation on the back side. That's how you test yourself. You're going to have lots of those. Area of a circle, circumference of a circle, area of a trapezoid, area of a square, surface area for a pyramid, volume of a prism. Those are all formulas you're going to have to know. So start, if you're not doing the vocab, you need to start. And if you're not making flashcards out of it, especially for these things that are formulas, you want to flashcard them so that you can quiz yourself so you can learn them. That's a good way of learning it. But if you don't learn the formulas, if you don't memorize the formulas, you aren't going to pass. And I can't make you, I mean, I can show you what you need to do to memorize the formulas. I can give you tips and tricks on how to do it, but in the end, it's up to you. You have to do it. I'm not going to give you the formulas. That's part of the learning that needs to take place. And once you've learned them, then you know how to apply them. All right. Today, let's talk about circumference of a circle. But before we do that, we need to review. Okay? Because this quiz is coming back to us, the central angles and stuff like that. So take a minute, spare a piece of paper, find the measure of arc BCD. In fact, tell you what we'll do. If someone wants to come up and demonstrate how they would do that, you could do it for all of us. Anybody, any volunteers? Answer the question. Find the measure of arc BCD. Anybody? Okay, then you can all do it on your own. Who can't keep their popcorn in the bag? Okay, let's look at it. Now, what's a lot easier if you have the picture in front of you is first thing you should probably be doing is saying, okay, I want to find the arc of BCD. That's what I'm looking for. Well, this actually is pretty easy. This angle is 90, so this arc is 90. I need to know this angle and this arc as well, but if this angle is 60, what's this angle going to be? This arc is going to be 120, and 90 and 120 is, there we go. Did you get 210? Find the value of x. Who can start by telling me the formula we'd use here? What have we got? Okay. The angle, what's the formula? Let's not put numbers in here. Let's do the formula. Angle equals arc 1 minus arc 2, yes. Okay, and it is minus. And arc 1 has to be the larger one, right?
Yes.
So, plugging our numbers in, the angle is the 35. Is 1/2 the larger arc minus the smaller arc. Now, when we did this on the quiz, a lot of people would put the angle in here and one of the arcs out here. You weren't putting numbers in the right spots in the formula. I had people who had the right formula, but they're putting things in the wrong places. But it's 4x minus 6x plus 30. You can't take the small one minus the large one. It doesn't work. It has to be large minus the small. That's nice. Good to know. So now we have to simplify this. The 6x minus 4x is 2x plus 30. Now I could multiply both sides by 2 or distribute the 1/2. Because they're both even numbers under their distributing 1/2 is actually pretty easy. So half of 2x is x, half of 30 is 15, and then we just subtract 15, and I get x equals 20. And we can check our answer pretty easy. If x is 20, then this is 80, and 6 times 20 plus 30 is 150. 150 minus 80 is 70. Half of 70 is 35. It works. But notice that the 35 and the 80 by itself, there's no relationship. You have to have the 150 there too. A lot of people on the quiz who are trying to do just half of this arc equals that angle. It doesn't work that way. You have to use both arcs. Sometimes we get lucky and it works, but usually not. Yeah. Yes. Probably. Yes. You could, because all you're doing is rearranging the equation. You're multiplying both sides by 2, so you get 2 angle equals arc 1 minus arc 2, and then you're saying 2 angle plus arc 2 equals arc 1. You're just rearranging the formula is what you're doing. It's the same formula. So I guess if you want to memorize the formula that way, it works. Okay. All right. Today we're going to talk about circumference. Don't forget, this is going to come up again on Tuesday. Circumference of a circle. Now, a lot of you, when you learned circumference formula originally, they taught it to you as this. Circumference equals 2 times pi times radius. The problem with that is, that's absolutely correct. There's nothing wrong with it. The problem is we learned the area formula then when we were a little bit older. We got pi r squared, which also used the pi, the r, and the number 2, but used them in a different way because the 2 is an exponent instead of a multiplier. But as one would expect, people mix these two up because they use the exact same variables and numbers, and they get confused. But we have something that we do, that I tend to do in geometry. You don't have to, but I know that 2 times the radius, if I just take the 2 here, 2 times the radius equals the diameter, so I could re-express this formula or relearn it as circumference equals pi times the diameter of the circle. So we're using a different variable instead of radius. And that helps eliminate confusion. There's nothing wrong with using this formula. It's perfectly correct, and it works great. But pi times diameter helps eliminate confusion later on. So you might want to think about making a change in the formula you know is for circumference. Because this is not like the first time you've ever seen the formula for circumference. All right, that's old. Now, just as a curiosity, the value of pi actually comes from this formula. If I take both sides of this equation and divide by diameter, I get pi as circumference divided by diameter. That is actually where pi comes from. I mean, the ancient Greeks, 2,500, 3,000 years ago, they came up with pi was defined as a ratio of circumference over the diameter of a circle. Before they even knew what the value was, they theorized that was going to be a constant. And then they worked on finding out what is the exact value of this number. And as you know, there is no exact value. It goes on and on and on forever. It's 3.14159265, et cetera, et cetera, et cetera, right? Okay? I know you did pi memorization as like a middle school thing. But it goes on. So that's actually this formula using diameter actually is taking us back to how this whole pi thing actually came about. Another reason I like it. So pretty simply, if I know the radius of a circle, say is 5 inches, what's the diameter going to be? So the diameter equals 10 inches. So the circumference is going to be the diameter times pi inches. It's that simple. And by the way, for the most part, we aren't going to do 10 times 3.14 because that's an approximation. I just leave it written in terms of pi. I leave it written 10 pi inches. If we must convert it sometimes, we will, but for the most part, we'll leave it in terms of pi. And this is kind of a summary of that. Circle with radius 10 centimeters, the diameter be 20. The circumference is diameter times pi, or 20 pi centimeters. Now, also note, circumference is a length measurement. It is not an area measurement. It's not centimeters squared or meters squared or inches squared or anything like that. It's a length measurement. We're measuring how long it is. When necessary, we use, and when we do have to estimate pi as a decimal, we generally just use 3.14. When do we do that? When we're doing application or word problems in a lot of cases. When they're asking, how far does the wheel roll? For example, a wheel 16 inches in diameter travels 200 revolutions. How far did it go? Well, I can easily find that one revolution is the circumference of the wheel, which would be 6 diameter times pi, 16 pi. 200 revolutions would be 200 times 16 pi, which would be 3,200 pi inches. But let's face it, 3,200 pi inches isn't a very good measurement for us. We probably want, because it's an actual story problem, real-world situation, we probably want to approximate. So I take 3,200 times 3.14, 10,048 inches. If I wanted to, then I could divide that by, so I had 10,048, 10048. I could divide that by 12. Try again. That's 837 1/3 feet, or divide that by 3. That's 279.1 yards. Okay. How many miles? I don't know how many inches in a mile. 5,280 times 12. So 5280 times 12. 63,630 inches in a mile. So if I take 10,048 divided by 63,360, it's 0.158 miles, 1.159 miles, a little over a tenth of a mile. Okay? So that's how it works. And again, we generally use 3.14 when it's a real-world situation like that, or if they give us values that have decimals in it to begin with. So like if they told you the radius is 2.63 inches, then we'd probably use a 3.14. We don't mix decimals and pi usually. Circumference is no big deal. You should be okay with circumference. It's very, very much a review topic. Arc length is different. This is where it starts getting interesting. Early in the chapter, if I said, what's the measure of this arc from B to D, You just said 140 degrees because you measured arc angle. But now, if I know the radius of the circle, I can actually find, well, how long is that? How many centimeters long is that? See, degrees doesn't give length. Degrees gives arc angle or arc measure. This is arc length versus arc measure. But how could we do that? Well, actually, it's very reasonable. First off, we have to figure out, well, how much is the whole circle? Okay, it's 360 degrees, right? And how many degrees of that circle am I using? When I have 140 out of 360 degrees, right? Now, what is the circumference of that whole circle? I did the whole thing. It's pi times diameter, right? What's the diameter of that circle going to be? 16 centimeters. So the circumference is 16 pi. And we want to know how much is right here. It's proportional thinking. It's proportional thinking. That's the equation that we're going to set up and solve. To find the arc length of BD, we're going to find the angle over the whole circle equals the arc length over the whole circle. Part over whole equals part over whole. And we set up a proportion, and we cross-multiply to solve that. So I'm going to reduce this to start with to make my life easier. And 14 over 36 would be 7 over 18. And so 7 times 16 pi equals 18x. 7 times 16 is 70, plus 42 is 112 pi. Is 18x divided by 18. So 112 divided by 18 is, I don't know what that is. Okay, we aren't going to decimalize it. We're going to leave it as a fraction. We're just going to reduce it. So 112 over 18 would be 56 over 9. Okay, because 2 goes into both those, and 3 does not go into 56. That's 56 pi over 9. Centimeters. Yeah, we don't approximate it. Okay. So there we are. That's our process. Now, sometimes our numbers do wind up a little bit messy in the end like that. But for the most part, we're dealing with messy numbers. For the most part, we're dealing with nice whole numbers. We just wind up with a proportion. And again, actually, I didn't realize this slide was next, but this work through the whole process again. Notice how we set up our proportion. Part of the circle in degrees, whole circle in degrees, which is always going to be 360. Part of the circle in arc, whole circle in arc, which is a circumference. When we really break it down, a lot of times this is the way we look at the formula. Although, just remember, part over whole equals part over whole is a lot easier than this formula. It's the same formula, it's just more specific. Central angle associated with my arc over 360, which is the whole circle, equals the arc length over the circumference. Arc length, by the way, is abbreviated normally by an italic or a cursive L for arc length, L for length. Okay? Over circumference, which is pi times diameter. Or, you may see this written theta over 360 equals L over pi d. Theta is a Greek letter. It's a Greek letter we use to indicate an unknown angle. It's like x. It's just that it's Greek instead of x. Because we often use theta to represent an angle in mathematics. That's what we do. All right, so let's set this one up. Now, By the way, this is one of those formulas, if I wanted to, I could rearrange the formula. If I multiply both sides by pi times diameter, I actually get this formula right here that's directly for the arc length. Arc length equals theta times pi times diameter over 360. So if you prefer to memorize it that way, that's fine. The problem is this formula works no matter what the unknown is. This formula only works if arc length is my only unknown, or works easily when arc length is my only unknown. So let's say we knew the arc length and we need to find the circumference. This formula worked great. This one, not so much. So just kind of keep that in mind. But here I want to find arc length ABC. So I start by finding the angle associated with it. If this is 150, what's this angle going to be? 210. So I take 210 over the whole circle equals the arc length over the circumference of the circle. The radius of the circle is 11 inches. So the diameter is 22, so the whole circumference is 22 pi. And again, we've got that. We're going to cross multiply. 20 over 36, actually, that's 7, and 36 would be 12 to reduce that. So 7 times 22 pi over 12 equals the arc length. That'd be 154 pi over 12, which would be 77 pi over 6, and it's inches. So a lot of times my final number winds up a little bit messy, but that's how we do it. That's arc length. We're out of here at 02. Okay. Here, this is just an application of it. We take both halves of the circle and make the whole circle plus these two sides. So it's the same basic idea. The radius here is 3. So we need the circumference of the whole circle, which would be 6 pi, plus, then these lengths would be 24 centimeters. That would be my answer. Because we've got a half circle and a half circle, to put them together, you get a whole circle. That's how much it would take, yes. That one we probably decimally approximate, wouldn't we? Mm-hmm. Well, to start, it's true, it's accurate. All right, that was it, your homework for tonight.